Hello everyone. In this lecture, I will take up 4 cross 4 key matrix. It's a peripheral which need to be interfaced with the core LPC1768. Here in total 16 switches are there corresponding to 16 keys. As and when any switch gets pressed, our core should understand the corresponding key being pressed. These keys, 16 keys, can denote any number, numeric number, any alphabet, and any other thing as per the programmer's logic. These keys can be used to depict that thing which our LPC1768 later on can understand as per the logic of programmer who will program this interfacing. So it is not static that these keys define static values. Anything which, as per the logic of programmer want code to understand, so it will go in that way. Now, whenever you will press it, our key, whenever being pressed, code should understand that this corresponding key being pressed. Here, the 4 cross 4 keys, in total 16 keys are arranged in, here you can see 4 rows and 4 columns. So in total 16 keys arranged in 4 cross 4 key matrix. Now in total, as we know, 100 pins are there in LPC1768. Out of 100 pins, only 70 can be used as GPIO pins, general purpose input output pins, or for interfacing mostly with peripherals. Now pins are limited. So suppose if we could have a liberty of using as many pins as possible, then we need not to arrange these keys in these switches and keys in 4 cross 4 16 uh, 4 cross 4 key matrix way. In that situation, corresponding to each switch, we could connect it with the corresponding pin, and as and when we press the switch, that pin will get some value, some logic, and that logic would have easily decided that the corresponding key being pressed or not. But problem is that our pins are limited in number. So somehow we don't want to overutilize our pins. We want to optimally utilize the pin. So pin configuration should be optimally utilized. How we can do it? Here, by arranging these switches nicely in certain order of this matrix, 4 cross 4 matrix, we can reduce our pin requirement. How we can do it? We will go to our next understanding. Now here I have arranged these switches in 4 columns, C1, C2, C3, C4, and 4 rows, R1, R2, R3, and R4. And these are all the switches. So here you're noticing the intersection, but these are loose wires. There is no intersection. The intersection will only happen whenever we will press this switch. The moment you will press the switch, corresponding row and column will intersect. And this is our LPC1768. Now these rows and columns are nicely arranged to what purpose it will solve. Initially, we have seen that if there would be no logic of arranging these keys in nice order of 4 cross 4, then at max we require 16 lines, 16 pins. But here we want to arrange our switches in certain ways so as to reduce our requirement of pins. Here we are using only 8 pins. So drastically we have reduced our requirement from 16 pin to 8 pins. Why? Corresponding to individual row, we require 1 pin. Corresponding to individual columns, we require 1 pin. So in total, 4 columns are there and 4 rows are there. So 4 rows corresponding to 4 rows, we require 4 pins. So those rows line, we will attach with the corresponding row pins, and likewise the columns will be attached to the corresponding column pins. Now this is all right, but we have to here understand that out of these 8 pins, whether all the 8 pins will be input pins, whether all the pins will be output pin, whether half of the pin will be input pin, half of the pin will be output pin. It depends on the logic, that how we actually wants to make out a logic, and out of that logic we want to read the corresponding switch being pressed. So here I will make you understand that what is the premise behind our logic and how our LPC 1768 will be configured for interfacing. So here we are using 8 pins: 1, 2, 3, 4, 5, 6, 7, 8. For rows, we have 4 pins. For columns, we have another 4 pins. Now these row pins we are making as input pins. So you can see the input arrows. These row pins are input pins. Input pins mean our core will always monitor these pins for certain inputs to come. And here the corresponding to columns, these columns are attached to 4 pins, and those all 4 pins are output pins. That means our core will write certain values, give some logic value to these output pins. Now how these output pins will be used subsequently, and later on how the monitoring pins or the input pins will be used by LPC 1768, we will go towards understanding this. All rows are initially grounded. That means initially there is no logic 1 over these pins. So if there is no logic, so cross represent that there is no logic right now. There is no logic 1 value right now. Logic 1, wherever I am using, that means positive voltage value. Here in case of LPC 1768, because 4 pins operate and they can withstand a voltage up till 3.3 voltage, so that is the level 1. So initially, if there is nothing, because every row is grounded, you can see here row 1 is grounded, row 2 is grounded, row 3 is grounded, row 4 is grounded. So initially when nothing is pressed, so that state LPC 1768 can make out that if nothing is pressed, by understanding and by just observing the pin configuration or the pin values, if the pin value is always 000 over all these 4 pins, that means nothing is being pressed. Now suppose if we want to press anything, any one of the switch, and particularly corresponding to that switch, our LPC 1768 should understand. Suppose corresponding to column 1, row 1, switch we want to press. Suppose we are targeting this switch, and if we want to press it, so initially the logic is 0 here because it is grounded. Suppose now you are pressing it. At the time of press, somehow we write the value, somehow we give the output value over these 4 pins. Corresponding to column 1, we give the value as 1, and for other rest of the columns we give the value 0. So in that situation, whenever the value come here and at the time you are pressing column 1, row 1 switch, that means this switch whenever you will press. So this one logic, because this is over this wire, it will go. And now there is a connection. Now once you will press this, there is a connection from there, it will go, it will come here, and then it will go to this input pin corresponding to row 1. Now no more row 1 will hold or will represent the value 0. Now row 1 will change from 0 to 1. And this change, our LPC 1768 is constantly monitoring. And in this way, and how exclusively corresponding to column 1 and row 1, we've been able to notice that this switch being pressed through this value. This value should be 1000. If you will make any other 0 as 1, then there would be a conflict. Then exclusively we can't claim that column 1 and row 1 being pressed. So that's why it is important that we will output on these 4 columns in this order. So initially we want to see, because it may be possible, it is in order we are checking. So because anything at a time user can press, but we are taking the liberty that our program will be run. At least these 4 values will be processed 1000 initially for column 1. Then next time in the same program, LPC 1768 will produce these 4 values over these pins 0100, and this one corresponds to column 2. Then third time for column 3, fourth time for column 4. So in this way, in one cycle, our LPC 1768 will keep on repeating this value over a cycle. So this cycle repeats this, that our LPC 1768 keep on repeating these values over these pins. So at a time, whenever user press, so obviously user will press that thing for a while. For a while for user will be 1 or 2 seconds, but for LPC 1768 in 1 or 2 seconds, because the cycle time is more, so it can repeat this process several times. So obviously at a time, uh, because user has pressed this for 1 or 2 seconds, and suppose initially the value is 100 and user has pressed column 2 and row 2. So this thing has been pressed. So initially, because the value is 100, initially the value will be 0 here corresponding to row 2. But the moment the output value over these pins will be 0100, then this one will go from here, and already we have pressed this switch, then it will traverse from here, and then 0 converts to 1. So the logic will change. The logic 0 will change to logic 1, means then LPC 1768 will notice certain positive voltage value. And then this cross mark depicts that correspond, there is 1 now, so means something is being pressed. Then how your LPC 1768 will figure out that what is being pressed. So it will notice that, okay, corresponding to row 2 something is being pressed, and there are 4 options available. This switch may be pressed, this switch may be pressed, this switch may be pressed, this switch may be pressed. Then at the time when it will notice 1 over row 2, then at that time it will also notice the corresponding column number which was 1. And in this case, the column number 1 was 1 at that time. So column number 2 and row number 2. In this way, always explicitly, exclusively, our core would be able to understand, would be able to make out the correct pin always. But here we have to always repeat this. How to keep on, we have to keep this thing in certain while loop, or means infinite while loop, so that these column values will get the corresponding one, and wherever there is a one, that means corresponding to that column, um, if any row being pressed, then that row will get the exact then that row will get the value 1 or the high logic. And then because those are input pins and our LPC1768 is constantly monitoring, the moment it will notice that there is 1 over any of the rows, then it will check the corresponding column values. And if, like, suppose the row 3 is 1, so this is row 3, row 3 is 1, then there are 4 possibilities. Either column 1 could be pressed, column 2 could be pressed, column 3, and column 4. So then it will notice the at the time when it the value transit from 0 to 1, at that time, what was the state of all 4 columns, which column was 1 at that time. And depending on whichever column was 1 at that time, and these are in our hand, because these things you can change. These things, row corresponding to rows, we are monitoring. So as and when any value becomes 1, then it triggers that something being pressed. Then over that row, 4 column options are available. And out of those 4 column options, we have to then zero in to any one specific column. Then to zero in and exclusively figure out which column was pressed, which column switch was pressed. Then at that time, what was the state of our column pins? Because that is in our hand. And how that is in our hand? Because we are constantly changing the value. So as and when it was 1, we will notice the value of our pin was this. How you can figure out that value? So using those GPIO registers. So this is all about the logic. In next lecture, I will walk you through the program responding to interfacing 4 cross 4 key matrix with core LPC1768.